guys here. It's going to be, an amazing podcast episode as always. I think with what you guys at Nethermind do, and then the questions that we're going to ask is going to get pretty hectic. But, to start things off, with the thing that we usually do is ask about you guys, Matteo, Antonio, how you got to Nethermind, what was your path before you got to Nethermind, and what are you guys doing now?
Do you want to go first, Matteo?
Yeah, we can go with Matteo first.
Yeah. So, so do you want to present you even what I've done before Nethermind?
Oh, yeah. So kind of like your path. Yeah.
Yeah. Okay, cool. So I started working in crypto since 2019, even if I know crypto since 2012. So, I was an early adopter, but yeah, okay. And so I started working in 2019 in a company making bots and MEV until 2022. I had a brief experience in a bridge, and then I joined Nethermind. And in Nethermind, I started working before with some activities for Starknet regarding MEV. And then I started working in the ZK team, and now is branded as privacy team. So privacy and ZK team. And and now I'm the team lead of the team.
Mm-hmm. Wow. Oh, what about you, Antonio?
Yeah,
I see that you're a cryptography engineer. That sounds very interesting.
Yeah, I guess. So, my story is somehow similar to Mateo's because I was getting my PhD from my university, but I decided to switch topics in the middle. So for some reason, the Spanish government wasn't so happy about it, so they decided to withdraw my grant. So I started working partially while I was getting the PhD, and that's how I started working on Web3. Mm-hmm. I started working in some small local companies, and then I started working as a cryptography researcher or cryptography engineer in some other companies. Then 3 years ago, I did join Nethermind as cryptography engineer. And yeah, so far it has been really good. And currently I'm working mostly on Stellar privacy payments.
Sounds amazing. Yeah, so we here at Arcane are building, kind of the same thing, private payments, compliance-ready privacy infrastructure for on-chain finance, to be more precise. Joining us here today is Max, our founder, product and strategy guy.
Wanted to say thank you guys for building what you built on Stellar, because that's what we do. So we are focused on building kind of the real products for business, and it was a great help for us to use the smart contracts that you guys created on Stellar. So this is a perfect collaboration, I think. So you create the tech like POC, and then we convert it into a real product that is used by businesses. Yeah, so great.
Yeah,
that's cool.
Yeah, and
cool.
Yeah, now that we got the introduction straight, just to set the topic straight for our podcast, we're talking with you guys, and Nethermind is one of the major engineering teams in blockchain infrastructure. I would say we have deep work across Ethereum, Starknet, cryptography, protocol engineering, security, also enterprise blockchain systems that we're going to be mentioning too. And I think to put this in a right way, we're going to be focusing this conversation around privacy preserving payments, the real engineering behind them. And we'll talk about how you guys got into ZK engineering and what changes when zero knowledge moves from theory into production, and how Stellar private payments work, and many other things Stellar. So just to kind of put things into perspective, zero knowledge has become one of the most talked about areas in crypto, I think. Apart from all the meme coin talk and Sailor buying another bunch of millions in dollars worth of Bitcoin. Zero knowledge, again, very different from the way people describe it online, in truth. And from the outside, it can sound like, a clean, privacy solution. You generate proof, you hide the data, you verify the result. And once engineers start working with, the circuits, the constraints, like proving the systems, I guess, also is there, and, performance limits and real users, that picture becomes, more demanding in explanation. And I'd like to start with the, your kind of like personal path before we got, as you got into Stellar private payments, and and the design choices around them. So how did you get into ZK engineering exactly, and what are you doing there now? And what surprised you once you were working in the cryptographic details rather than just reading about the concepts? Maybe we can go with Matteo first, and then Antonio.
Yeah. Okay. Thank you. Yeah. Good question. It's also funny because me and Antonio have different. We arrive in ZK with two different ways. So I discovered ZK when SP1 was released. So I think what was 2 years ago. And it was during my brief experience with the bridge. So we came out to what ZK was and what SP1 also was, and the idea was to build a ZK client for the bridge. So I was involved in ZK two years ago, and then when I joined Nethermind. There was like 1 year ago. The Nethermind decided to form this group, so the ZK engineering team, and we started scoping and understanding more what ZK is or how we can improve it. And what I've done is multiple things, like. I started when we started doing ZK. I started benchmarking zkVMs. So initially, I was on that part, so using zkVMs for Ethereum proving or even other other programs. And the idea was to try to benchmark and see which zkVM was the fastest one, but also the most, I would say, ready on production at that time. And then I started moving on building we also with Stellar. So our work with them started 1 year ago, not only for the SPP, but even for writing the RISC Zero verifier for the Stellar. Also, we were involved in the protocol 25. So I also had the foundation, the SDF, to add the precompiles for the BM curve. And then I'm also we are also maintaining the Noir thing. So this was my road to ZK. So I'm stepping from project to project, and yeah.
It's interesting.
Do zkVMs feel like cheating? So you're not like doing the real ZK. You're just like writing some code.
Oh.
You don't know what's like under the hood.
No, at that time it wasn't cheating. Maybe sometimes there were. I wouldn't say that. So their timings were, were okay. So what they say they were okay. And at that time there was the competition between RISC Zero and SP1, and in our benchmarks we ever find out that RISC Zero was a bit slower than SP1, but then also Zisk came along, and I think that is now currently even the fastest one, or it was when I was benchmarking. And yeah, so that it was funny, because you can see how the tricks that they were using to speed up the proving time, like the precompiles and all the things.
Yeah.
And it was also, it wasn't quite easy to write some programs in the RISC Zero. Sorry, in the zkVMs, not only in RISC Zero, because we also benchmarking Jolt at that time, Nexus, Valida, but yeah, there's so many.
Yeah, quite a lot of projects. Yeah, really not all of them are that active today. I'm not sure like what's happened to Jolt. I haven't heard of them like for quite some time, even though they were like super promising, but they pretty much disappeared, I think.
They are kept building. I know that they have their stack is very good, and I know that, for example, Layer Zero builds their new product based on Jolt. So they're using a custom version of Jolt, and yeah, many others. I think there is another product that it's using Jolt. I think that someone is using Jolt or part of Jolt stack for even doing AI for verifying AI.
Everyone tries to do AI, something with AI.
If there's no AI in it, we're not going to do it.
AI pretty much replaced meme coins in some sense. Yeah.
But
So, yeah.
Same question goes for Antonio. We'd like to hear your path to ZK.
Sure. Okay, so I have good news. It starts with AI, because I was actually doing AI in 2017, 19. And then I decided to switch topics, right? I wasn't like really big fan of AI in the moment. So I decided to switch the topic of my PhD into cryptography. And I did focus on applied cryptography on electronic voting and anonymous identification. And like my first approach or my first contact with ZK Proofs was mostly academical, right? Like you studied like a Snore protocol in university, seemed pretty cool, pretty complicated, but also pretty scope, right? Like basically you couldn't prove many things. It was pretty limited. It was before like we have things like Pinocchio or like more general proof systems that were being used in more places, right? So that was my first approach. And then when I dive into electronic voting, I saw that basically you have like either print signature or blind signature based or partially or fully homomorphic systems or ZK based voting systems, right? And that was like my first approach to more general ZK proving systems. And after that, when joining different Web3 companies, I started working with some DSLs. I started reviewing like a little bit more detail, like the seminal papers, like a Growth 16 paper, for example. And yeah, in Nethermind, I would say that I have been always kind of focused or ZK related, mostly in two ways, right? So either I was working in a project with a client that has like some really specific scenario and he needs like some ad hoc privacy solution for them, or implementing like more theoretical work, right? I put cryptography engineer because I'm not a mathematician and many things go above my head sometimes. But we are lucky in Nethermind. We have Albert Garreta, our cryptographer, and many projects we work together were basically building the code for their papers, right? So building the real implementation of some folding schemes or like some proving systems for domain-specific problems. And that's how I got into ZK mostly.
Well, and with that being said, I kind of want to move to how the privacy pool works. So we can kind of move to the Stellar private payments, the main topic of today's podcast, because those same privacy pools, they can sound abstract. For the non-engineers, especially me, the basic question is simple: like, what information goes into the system, what remains hidden, and what can still be checked so the the payment flow works safely, compliantly, and this matters for, I think, our audience and for all of the like non-engineer people, because fintech teams need privacy they can reason about, and they need to know what the system protects and what it proves. And so I'd like to give our listeners a practical mental model about all of this before we get into the design details. So for someone who has not seen the Stellar private payment design, how would you describe the privacy pool in practical terms? Like what enters the pool, what stays private, and what still needs to be like verifiable?
Sure. Do you mind if I take this one, Matteo? Or
Yeah. Go on.
Okay, so what's the motivation or like the problem, right? Like we have blockchains, they're wonderful, maybe not the fastest ones, but really nice, really centralized. The main problem is that everything is public, right? There are many scenarios in which you might want to have some degree of privacy, right? Because you don't want to see people seeing how much you pay to who and for what reason. So privacy pools are proposed as kind of a privacy solution for this. In a transaction, usually you have a sender, an amount, and a receiver. And what privacy pools try to break is the link between the sender and the receiver, right? So not everything is private. Like CK proofs are not a magic wand that give you privacy for free, right? Of course. So what we do is, instead of sending money to someone directly, you would first send it to the privacy pool, right? At the end of the day, like if you think of the privacy pool as a black box, you are just trying to break the link between you and the receiver, right? And we also have like some additional features that let you operate within the pool privately, so that basically you can make some claims like, I deposited some money in the past and I would like to move it inside the pool in a different way, or make some changes, without actually revealing which specific amount you deposited or how you are splitting that money, right? What's public? Basically, every incoming and outgoing transaction, it's public, right? That's why it's important to maintain like good privacy hygiene, because if you deposit and withdraw to the same address, basically you are not getting much privacy, right? Basically, you are revealing yourself. But what's private? Okay, so once you made the original deposit in which the amount is public, you have like a node, a discrete UTXO that belongs to you in the pool, and you can later on, through CK proofs, demonstrate that you own a node for some value without revealing the specific value or the specific node, and then you can spend it or you can manage it very privately, right? So in short, privacy pools are a way to give you some level of privacy, and basically we want to hide the sender and the receiver relation.
That's very interesting. I think, Max, maybe you can add something to that. Do you have a follow-up question?
I have. Yeah, I think it's a great explanation. I'm just curious, from a practical perspective, what's your guys feeling? Because obviously, public blockchains, like the simplest operation for a public blockchain is just to move assets from one address to another address. So this is super straightforward, cheap, and so on, reliable. Things apparently get more tricky when it comes to private payments that use ZK pools. So your transactions are bigger, so you spend more gas. And also there are some caveats, like we are dealing with UTXOs in a privacy pool, and like liquidity can get fragmented into multiple UTXO nodes, and like you have 10 nodes, like $10 each, but it's hard to send like the whole amount because it's split into multiple nodes. I'm just curious what you guys are thinking about it, and what possible ways to improve this. I would call it like developer UX, maybe. How this can be done. Yeah, just a very open question.
Absolutely. Like I completely agree, right? You pay a price for everything, right? There's always a trade-off in engineering, and basically usability or UX is something that gets quite degraded, right? Not only because it's worse, it's slower, it requires more steps. You need to be careful. You need to maintain proper security hygiene, but also because you are making the burden on top of the average user, right? Like, and the average user might not be aware of how the UTXO model or how he needs to split the nodes to make a payment, right? At the end of the day, he just wants to go from A to B in a private manner, right? And we try, of course. I think that we are making good progress, right? We are trying to basically abstract most of the complexities away, right? So, for example, first of all, the Stellar Privacy Payments code is public. It's open source, so anyone can see it. So we just deployed today a new deployment script that basically abstract most of the complexity for deploying different pools with different compliance or accessing policies, so that the user can control it from a simple script, right? He doesn't really know about proving keys or artifacts, different circuits. He doesn't see that. He just sees some flags and he tries to deployment in a simple manner. Or when, like for example, like the liquidity fragmentation that Max mentioned. So you want to make a payment for value 10, but you have two nodes, one it's 7, one it's 4, right? So basically, you have the next up problem, and you need to make an intermediate transaction to basically, or an intermediate step to make sure that you can pay the amount 10 to someone. We hide that away from the user, right? So that he doesn't really see how many transactions or how many proofs he really needs to generate, right? He just sees that he can send 10 from A to B, and that's it. That being said, it's a never-ending war, right? Like there's always like some price you need to pay, and the user gets a slightly worse UX. But I think it's worth because in change you get privacy.
Mm-hmm. That's really interesting. That kind of touches on the topic of the designs behind those choices in the pool. And as we mentioned, every privacy system has the trade-offs that you mentioned, Antonio. A design can aim for stronger privacy. It may be easier integration or lower proving costs, better wallet UX, or something simpler about the compliance review. And in a payment system, those choices become even more important because the user. So for instance, me, maybe like they expect the flow to feel normal, but they don't want to understand like note commitments, nullifiers, proof generation, just to send that money, as we mentioned in the example of just like the simplest transaction. And I want to understand the engineering choices behind the user experience. So what were like the main design choices behind the privacy pool, especially around node structure, same nullifiers, asset support, user flow, and where did you like balance like privacy guarantees with operational simplicity? Okay. Maybe Matteo can take that one.
Oh no, if you want, Antonio, you can go and then I can extend.
Okay, sure.
Yeah.
Happy to do it. So that's a great question. I guess the question is, will we design the system again with the current features we want to support? That's a good question. I'm not completely sure, because everything you make, it's a trade-off, right? Basically, you don't have a lot of flexibility in arithmetic circuits, right? So it's always a design choice what you want to include in the node or not. So basically, there was like two decisions that made us design the node this way. So basically, a node right now, things are going to be changing, right? Because we are continually working and we are introducing breaking changes since we are on testnet. But right now, a node is basically like the node amount that you have deposited, a random blinding value, right, to keep the node private and unique, and your public key, right? This is not really a public key in the sense that it doesn't have like signing capabilities, but it's a field element that we derive from another field element we call private key, and it's tied to your wallet, right? So we only obtain like these three elements inside the leaf. One of the design decisions that motivated us to do this was, the first one is that it was pretty similar to what other privacy pools were already using, right? And since we were developing everything from scratch in Soroban and Stellar and the support, we decided to go like, okay, we can iterate later. Let's build something that works first, right? And once we have that, we can decide if we want to change some things. And the second point is we also wanted like to build at least like some basic compliance mechanisms, right? Like they are needed, institutions need them, and users usually also want them, right? Like we'll still give the user the chance to deploy a pool without compliance checks, right? Because at the end of the day, that's a personal decision. but we wanted to support some basic compliance. And for this, we took a look to the privacy paper, and we basically decided to use association sets, right? Association set providers. And basically, I'm referring to the Vitalik paper, and it basically describes association sets as a set of deposits, right? But we decided to include the public key in the node so that we can define association sets at the level of the public key, right? Which basically gives you the chance to allow or disallow all the nodes that belong to a public key instead of individual deposits individually, right? And that was one of the main the design decisions we take on the early days, and that's why the node is designed this way. It gives us a stronger control on the compliance mechanisms, and we might extend this in the future to also allow for like individual nodes screening, right?
I had a hard time understanding that. I'm going to be honest.
Sorry.
I tried to make my best to connect the dots, but I think I got the general idea. And
I'm curious, really. So there's like ASPs. I think they got more popular once privacy pools. I mean, like as the name of the protocol, the privacy pools, right?
Yeah.
Got released. But I was really trying to understand, like, what was the decision behind using that particular design? So I'm not sure. I don't quite remember. Do you guys have the same thing on Stellar, like exactly the same? So there is like, so you are first depositing into this like temporary place, and then your deposit has to be approved, and then like Merkle tree root has to be updated, and like is it this process, or do you do something else?
Somehow similar. Oh, sorry, Matteo, do you want to take this one?
Yeah, okay. It's similar. So ASP, so association sets are Merkle trees. So you don't have to wait a certain amount of time, like other protocols they're doing in order to deposit the money. So the funds or the tokens in the privacy pool, and that's because how we build the privacy pools, but also the circuits, because this check is inside the circuits. What we're going to do is we are checking that your address, so the address that you're using to deposit the money, I keep saying money, but it can be everything. So the token, the token that you want to deposit on the privacy pool is inside or is not inside in the EASP, so in the Merkle tree. So so when you're going to deposit on this privacy pool, you also because you're also proving, so you're computing these circuits, you're also proving that you are or you're not in these Merkle trees. And if you are in these Merkle trees, it depends, because if you are in the ASP, this means that you can deposit, and you can see like a whitelist. So where you can deposit and use the privacy pool, and non-ASP are the opposite. So you cannot operate with that. And when we started doing that, the idea was to build a tool also for doing some KIC. So the idea was you have your privacy pool, you have your ASP. This ASP is handled by you or by an external service, and you have to perform some KIC. This organization, adds your address in the ASP, and then you can operate to that. So we in a certain sense we are moving out the time to deposit. So the deposit and withdrawals are almost instant, except you have to wait for the transaction to be in the block. But we are moving away that part from you have to be KIC. So maybe you have, before using these privacy pools, you have to be whitelisted. And just two quick point that I want to add on this. The cool part about the things that are privacy pools is that so I've seen many people that when they talk about privacy pools are talking like with money, with funds. So you, I don't know, want to put Stellar tokens, USDC, but they are, in a certain sense, they are agnostic. So they are token agnostic. So you can, the cool part is that you can deploy a privacy pool and use for whatever you want. So you just need to tokenize or have a token or a representation of what you want, and then start using it. Yeah, sorry for this off topic, but yeah, I wanted.
Yeah.
Before forgetting it, I want
Yeah.
Also,
obviously, compliance is a big part, and today, especially when we are in the cycle where institutions matter most, probably for everyone. Everyone tries to onboard like institution, regulated entities and enterprises, and so on. And compliance is really important, but like compliance is also very different for different companies. So you cannot hard code anything into your protocol, right? So you just have to build a system that is flexible enough to adapt to meet the requirements of a particular company. And this is also like the problem we are solving ourselves, right? So there are a bunch of different KYT providers, like really IML, KYT is know your transaction. I know it's like not that widespread as KYC, for example. But so it's also something we are taking some time to solve. So I was just curious about your thoughts, and thanks for sharing that.
And also as you said, I think it's not mine. I think that Tomer said this, but privacy is more like a spectrum, and I like this phrase because for retail, so everyone has a different concept of privacy, and not because maybe I think, okay, I want be full private, so I want that no one's know what I do with my money, but probably also everyone want to do that, but when we talk with institutions, they have to follow some rules, and they have to showcase or tell to regulators or auditors to see what they're doing, even inside the privacy pool. So I know the problems that you were also referring, and there are many ways to also add, or in a certain sense, or even weaken, I would say, so the privacy, because when you start adding, for example, viewing keys or other selective disclosure features or any others, so in a certain sense, you are removing parts of your privacy. So you're not fully private, as other solutions or mixer are, but these are required for institutions. And as Antonio said before, what we aim to do is also to provide an SDK in order to opt in or opt out these features. So yeah.
And it's really, so you mentioned selective disclosure. It would be great if you guys could go a little deeper into this, another buzzword in the world of compliance. Selective disclosure.
Maybe.
Turpal, if you're talking, you are muted.
So I actually had a question about selective disclosure. I kind of want to get to that too. But on the topic of what we mentioned with compliance, I wanted to ask you guys how and where ZK actually helps compliance, because at Arcane, we spend a lot of time on the phrase compliance-ready privacy, and the goal is, of course, private financial activity. And ZK proofs can prove facts without exposing the underlying data, yada yada yada. And so I want to separate what ZK can solve from what still needs product, legal and operational design, and also, touching on the topic of selective disclosure. This is like one of the hardest parts of making privacy acceptable for financial institutions. Again, because when you hear selective disclosure, you wonder, okay, how is that even possible? But what makes that selective disclosure hard to design well, especially when users, even like issuers, auditors, compliance teams, they still may need different views of the same private payment system.
So selective disclosure, it's really funny because basically you have two parties, the user and the authority that wants to see some proofs, and they basically have like antagonic objectives or interest, because basically the user doesn't want to reveal too much, and maybe like let's say it's a tax authority, right, or I don't know, like an exchange, right? Basically they want to know as much as possible, right? So I guess like from the engineering point of view, it's not that complex to implement, but the most difficult part is how do you decide which features and how much you want to reveal, right? And for example, like this also ties with the pull or not commitment structure, right? For example, in our current system, like revealing the nullifier, lets other third parties know if you have already spent or not a node, right? Because that's public information that it's stored in the smart contract and they can check. But they cannot spend the node even if they have the nullifier, because in order to do so, you're required to sign with your private key, right? So in this case, for selective disclosure, this means that we can also optionally give the user the chance to not only disclose the amount that he has in a node, but also if he has spent it or not, right? Which might be useful for different purposes. Right now, we support selective disclosure, and basically the user reveals the amount of a specific node and if he has been spent or not. He can generate, we bind this information revealed to a context, so proof cannot be replayed, and basically give the chance to the user to also generate batch proofs. So because you might have more than one node in the pool probably. So basically, we give the user the chance to take a list of nodes, if they're spent or not, and decide how much he wants to reveal to someone else. If that third party is going to be happy or not with the information for selective disclosure, that's an open problem, as you mentioned, right? Like they might not be happy or they might not consider it enough.
Yeah. I mean, that was actually an amazing answer, especially for someone that is not as technically adept with all things ZK, and selective disclosure. That was something that kind of opened my eyes. But with that being said, I kind of want to move to Stellar, Soroban, and production barriers, because Nethermind, from what I read, you guys have strong experience across Ethereum, Starknet. So the choice of Stellar and Soroban is especially interesting because Stellar has already, made that focus on payments very clear. There's strong stablecoin use cases, a history of asset movement, a big history of asset movement, and Soroban adds smart contract functionality, which makes the whole process more complex for privacy logic. And I want to understand the chain choice from an engineering perspective rather than just a marketing one, because I'm like the marketing guy. So why build this kind of like private payment system on Stellar and Soroban specifically? And to I guess to add to that, what did you find about Stellar that made it maybe easier, and what would have been harder on Ethereum, Starknet, or any other like smart contract environment?
Do you want to take that one, or
If you want, you can take it. Otherwise, I can. Yeah.
It's fine. It's fine.
Okay.
So should I? Okay, I'll take it. Sorry.
Right.
So basically, we already have, as Matteo mentioned, like some relationship with Stellar, and we were trying to help them basically bring privacy into the chain, right? Like privacy is a big thing right now. It has been always a big thing, but more important recently, I would say. So they basically wanted to know like how to be compliant, how to build primitives, what primitives they should support, what host functions they need to support if they want to be cross-compatible, if they want to support privacy, right? And we were already helping them, like building the VM, the cross-16 verifier, things like that. So basically, it evolved pretty naturally from that. They wanted to bring different privacy solutions, and I know that the SDA is working with different privacy teams, right, to build like different privacy primitives. So we decided, okay, we have the expertise, why not, right? And I have to say that this is my personal opinion, but I'm quite satisfied with Soroban, right? Like I really appreciate the fact that we can access host functions that are more efficient. I really like that we can develop our whole stack basically in Rust, right? Because you can develop Soroban contracts with Rust and the Soroban SDK. So that's really nice. Everything is inside like the same project. You can use Cargo for everything, and it works really well. Something that was a little bit harder, I have to mention it, is events, right? Usually, privacy pools rely on blockchain events to let people know what's going inside the pool, right? Because when users need to generate proofs, they need some kind of information, right? So basically, if you want to prove that you own a node at a specific index, you need to know what's the current state of the Merkle tree, right? Usually, privacy pools do that through events. That's the common. Ethereum does it. In Stellar, of course, we have events. That's for sure. But events are like second-class citizens, I would say, because they are only maintained, I think, that 7 days by the RBC nodes. So after that, they get ditched, right? They get destroyed. You can, of course, run a full node, but we try to not make the average user run a full node, right? So we have some issues with that. We are developing a boot node that now the user can either run locally or connect to one, so that basically we store and we maintain like access to these events, so users can gather information from there and they can still use the pool, right? But yeah, I would say that I'm really happy with Soroban on the efficiency level and being able to develop everything on Rust, but events were a little bit hard.
I mean, that was really great to hear, because at the crux of it, it becomes a question of preference. And I'm really glad that you share your preference to Soroban, because it makes things easier. And I think it was, I guess, like a pretty neutral answer. You don't throw shade at others, at other chains, and you keep your favorite there. But things are very clear to me here. And
I have a tiny off-top question. So with like all the AI dev tooling, everyone is talking about it. What's your experience, guys, with using? Because obviously you are writing very non-trivial code, right? It's not like creating some front end, which obviously AI can easily do for you. But like, what's your experience? So what's the percentage of the code you are writing manually comparing to like the code that is generated by Claude, Codex, whatever?
Very, very spicy question, Max.
Well,
yeah, I can take it. Yeah,
it's a good one.
Yeah, I think it's
Yeah, it depends on when you ask, discussion. Because if you ask me, I think 7 months ago, so before, what was Opus 4.6?
Yeah, for me it was 4.6.
Yeah, even for me, before December, it was like 99% of my code was written by hand and 1% by AI. And the 1% was just some boilerplate. And that was before December. Then in December, things started to change. And now, at least for me, I think that now I'm probably, it's half of my time is, so probably code is, so I'm not involved in the, I have to take, I'm not directly involved in the SPP, I'm involved in other projects, but also related to ZK things, so in ZK projects. And my time is, I think that is half and half now. It also depends on which language you're using for the circuits. If you're using Noir or Circum, for example, with Noir, Opus, and even ChatGPT, what was 4.6 they were bad. 4.08, they are good. They are, at least for Noir, they are writing good circuits. They still don't, but you have to review manually all the code, because there are, not only because you have to be sure that that they are writing good, the correct code, but it's because they don't know how to write a circuit, and that is the big point. Like, for example, when you have to hash so you have to hash a value, and what I've seen, for example, in Noir, is that they're just using, and you want to hash, let's say, with Poseidon. They're just call the Poseidon function and hash the value. But you have to know that you also have to add an extra value in order to be sure that you're not getting two. So with this, okay, I know that you know the problems, and they're not doing it. So if you're not aware how to write these circuits, you not get these bugs. So yeah, I'm using AI for doing this, but have to manually review everything. And there are also some other tricks. And in our team, because our team, we are lucky, because in our team, the people, in our team is working on almost all stack of ZK. So we have some engineers that are writing low-level code, so ZK, so like in ProofKit. And when I talk with them, they say that for optimization, sometimes they're not very good. I'm not sure about Fable, to be honest, because I never asked them how if they ever use Fable. But
I was going to ask about Fable, but thank you for clarifying that. Go on.
Yeah. Okay. And what I was saying, for these tricks, so optimizations, like you have to, because again, you have to, I don't know, you want to improve your matrix multiplication, so at the CPU level, so the instructions as like in assembly. AI sometimes fails with that. So we're not still on that. And with Fable, at least for me, my relationship with Fable is weird, because due to the blocks that they have with the cybersecurity, half of my time they find out that it thinks that I'm doing some cybersecurity things, so I cannot use Fable.
Okay.
But overall, I've seen also as not a huge step, but a good step. So yeah.
That's really interesting to hear, because I guess that difference for you, so before it was 99%, now it's kind of half and half. There must have been that very big change, update to whatever happened with the coding capabilities of Opus, especially because now you have Fable. There was also another one that I haven't gotten my hands to, but I'm gonna try and create something interesting there. And I had a really fun time pretending that I understood all the technical things that you were explaining. I hope that the viewer that is going to be watching this is going to have much better time, processing that. But with that being said, I wanted to get back to the question that I had, before we asked about the AI. So Antonio mentioned that there are, things that are good on Soroban, but if there are any lessons from Ethereum and Starknet, because I wanted to get into that.
Sorry.
So I was gonna ask, because Nethermind's background gives this useful comparison point. Ethereum has large developer base, like probably the largest. That there's mature tooling, and I'd like to know what knowledge transferred well from Ethereum and Starknet into what you guys are doing right now. So what transferred well and what had to be rethought, and did Nethermind's Ethereum and Starknet experience influence what you guys are doing with Stellar private payments today?
Yeah. Okay. So for Starknet I would say that Starknet is a very, I would say not a different chain, but his fundamentals, how the things that they build on Starknet, they are, there are some differences. Like, for example, they have their Cairo their Cairo language, and it's very similar to Rust in that case. But the cool part about Cairo is that when you write, so you can write the smart contracts, and they're gonna generate the Stark proofs, because Starknet is based on Stark, on Stark's proofs. So they're gonna generate all the Starks for you. So they are abstracting all these difficulties, or how the chain works from you, and so you have to use Cairo as a language, and they are trying to be as similar as possible to for example, for Solidity. But again, they have good features that honestly I like, and that I find out also with on Stellar, like, for example, account abstraction, or how you can sign, and you can have different signers for your transaction, for these smart contract calls. So these things, they are, I find out even on Stellar, and I personally like it, and I hope that they're gonna change, gonna be also in Ethereum, because I think that they are very good jump ahead with the user experience. So for Starknet, I found these things, and for Ethereum, I except for the language, so you are using, and the tools that you are using, that I think that in a certain sense are better on Stellar, because you're using the Rust. So the cool part about Stellar is that they decided to have Soroban as a WASM environment. So you're executing WASM binaries, and these also, and they're using also Rust, and the full stacks of Rust. So you have Cargo, you have the LSP for Rust. So you don't have to build tools like you have to do with the AVM. So in this part is better than Stellar, than Ethereum. But on the implementation details, or on how to think about how you implement privacy pools, I didn't find any differences. They're not. I didn't find. There obviously they are different chains, as you said, with different, as also you said, with different objectives. So aims, like Stellar is built for payments, so they built with payments in mind. Ethereum was more a general thing, so it's general chain. So you have obviously different things, like different resources, different limits, but we didn't see any measure blocker or any fundamental constraints in both chains.
Yeah, well, I can see that there's definitely some patterns that translated well, and I think we can all admit that we love Stellar more than anything else. It can be the easy answer to that question, I guess. Max, do you have anything to add to that? Because you guys were building on Stellar. Would there be any difference building on Ethereum, anywhere else?
Oh yeah, I also love to listen to your thoughts.
From our so we as a team also had a lot of, so we spent like almost 3 years building private on-chain private apps. So we have a protocol on Alio where they have also like their custom zkVM, their own Leo language, and their pretty unique design. And yeah, we tried a lot of privacy stacks, both zk and FHE and stuff like that. But well, I think now it's the time for crypto industry to maybe like change the focus a little bit from the tech stacks to the real business. Like, why are we doing this? Like, who is the user? Like good old questions that are usually asked by startups. And yeah, so now we are more so the main reason for us to come to Stellar is that we are aligned, we are totally aligned with Stellar team on like how the privacy is important, the compliance is important. So, and Stellar has a lot of protocols there and companies around payments, around real world assets. So the types of companies that benefit most from compliant privacy. So this was our main reason to focus on Stellar, and obviously the tech should be there. It's a matter of preference at the end of the day. Let's be honest. Like we see pretty much the same protocols exist on like Ethereum, Solana, on Stellar. So at the end of the day, smart engineers figure out how to build things on various virtual machines.
That's you guys.
Yeah, yeah, but it's great.
Talking about you.
As Stellar, I think like multiple upgrades. Even this year, there were a bunch of upgrades for the like core Stellar protocol to support more zk systems, to like do more optimizations around, especially like focused on privacy, basically. So I think Stellar is the great place, and I think Tomer recently published, like retweeted the report by Electric Capital, I believe, which showed that Stellar is one of the fastest growing ecosystems in terms of number of active developers that use the chain. So yeah, Stellar is awesome. Yeah.
Yeah.
So to kind of wrap it up, we're going to be asking our last question. We have already gone beyond the things that we wanted to discuss. When it comes to private payments and all things compliance ready, zk pools, etc. And now that Max has set this good like stage for Stellar, there's a growing number of active developers. Tomer, great guy, reposted our article, by the way. There was a thing that was kind of bugging me about all of this, because this is not, like on a global scale yet. It's very early in terms of crypto. There has been some maturity, but private on-chain finance will probably start where the need is strongest. So payroll teams, they maybe don't want their salaries visible to the whole market. Treasury teams, they don't want to show every operating transfer that they have exposed. Businesses don't want counterparties, amounts and timing, available to competitors, for instance. And this is something that we discussed with Alessandro from Stellar on our podcast. And at the same time, what we have here is the regulators and auditors. They need more like controlled access when rules require it. And I want to end on a realistic view of where privacy becomes a standard feature in these financial products. Where do you think private on-chain finance becomes useful first? Would it be payroll, stablecoin transfers, treasury operations, B2B payments? There's a lot of things there. And what is your overall vision on what the future holds for you guys at Nethermind in general? Maybe Antonio can take this one.
Yeah, it's quite a good question. So I'll try to answer the two parts. So the first one is where do I see privacy becoming like useful first? I mean, it really depends, but like, let's say we have been talking about privacy pools today. So let's say, so for example, like the integration with payrolls for a privacy pool, it's quite cool, right? Like you can actually connect it quite directly. You get benefited because of the volume, right? Because the amount of privacy that you get depends on the volume and the amount of users that are trading inside the pool. So it's a great relation, and then you can decide where do you want to send that and how privately, right? So I think that I'm not saying that they are going to be the most popular ones, but I'm saying that some of them are more straightforward to implement, and they might be ready earlier than others, right? I will have all the answers in the future. I hope always. But I think that like some of them pay really well, right? Like for example, like Payroll is straightforward. The UX is getting better, and like you are not going to, at the end of the day, like the one receiving the payment is going to receive it, right? So you only complicate one side of the equation, not the two of them. And related to Nethermind, I hope that we continue working on privacy projects. Of course, I'm a really big fan of ZK and privacy. And yeah, we hope to bring more privacy to the ecosystem and help institutions and help teams to be more private.
Mm-hmm. Absolutely. Maybe Matteo, anything to add to that?
I think that maybe I don't know, maybe, but I think that maybe even B2B can be more interested in this than the payroll, because payroll are very cool. I'm not going against what Antonio is saying, but I think that if two companies they want, so suppose that you have two companies that they are not in the same country, and they have to make some payments. And you're going to Swift, so you're going to use the Swift, the transfers. Yeah, sorry. But yeah, it's cost a lot and it's also slow. So if you can do on chain with a fraction of the cost, and being kept private, but also be regulated and allow some compliancy, or make the regulators and people, the government happy that you're not breaching any law. That can be even a great product. So yeah.
I mean, you're definitely right. You have to keep the government happy, especially because with all things, going into institutional, there has been this big surge of, legal, regulatory, and of course, compliance heavy rules that you have to follow. And I think so far, the job being done there is very good. And thank you guys for joining us today. I think this was actually a really useful look at what privacy preserving payments require in practice, like cryptography, system design, compliance workflows, chain level, the trade-offs, everything working together, and where we will see that, first strong integration of compliance ready privacy on chain going from this point on. And thank you for expanding on that very well. And so, yeah, this was it. I think we can say our goodbyes and actually close it out. Maybe Max, you wanted to add anything before we go?
No, nothing specific. Yeah, thanks a lot, guys, for joining this conversation. Yeah, it was a pleasure talking to you.
Yeah.
Hope to work more with you using your results on Stellar, maybe somewhere else too. Yeah.
Okay, wonderful.
Me too. Thank you.
It's been more than an hour. I hope you guys didn't get bored by my basic questions, but
it's fine.
No. I always enjoy,
things like not technically heavy. I tried my best to form those questions on a marketing side, but perhaps I should have given you more freedom to expand on things like the way you see them, because it was really interesting to hear the technical side of things. I'm gonna have my I'm gonna have to rewatch this podcast to understand it fully, but hopefully I'll get there one day.
You can edit me out of the way if I get too technical. No problem.
Absolutely not. Absolutely not. That was actually really good. Antonio, thank you for your in-depth look at the technical side of things. Matteo, you had a really good take on compliance, privacy things, and I can see why now you are the privacy team lead at Nethermind. There's definitely a lot of things to consider here when we're talking about this topic, and you're right. You can run like here, you can run here, and you just manage to gather everything and like put it in a fashionable sense that even I, not a technical guy, can chew and understand. So, again, thank you guys very much. It was a pleasure, and here's to new work that we'll be doing in the future.
Okay, likewise, guys.
Thank you.
Thank you so much.
Thank you for having us. Bye.